small values of x is given by the root of 1 minus x over 4 over 1 plus x over 4 is given by 1 minus x over 4 plus x squared over 32. So basically what are we going to be doing here? We're going to be finding how many terms? 1, 2, 3. So we are finding the first 3 terms. Then by setting x equals to 1 over 16, we shall determine the value of the root of 63 over 65. Now the solution. So the first step here is to split the numerator and the denominator. So this means when you have this root, remember this root is over everything. So we can split the 2 and we say 1 minus x over 4, then over 1 plus x over 4. So remember, this is the same as saying first of all power a half. So by the laws of indices. So we have that as power half. Then this half can be on the denominator and also the numerator. So you can have 1 minus x over 4. Then into bracket we have a half. Then over 1 plus x over 4 into bracket a half. This one again simplifies. When you have a power, when you have a term and you want to bring it at the numerator, you can do that, but now negate the power in the denominator. So you shall have 1 minus x over 4 to power a half, then 1 plus x over 4. Then since this one was a half, it becomes negative of a half. So basically by the end of the day, we're going to be finding the expansion of this, then we shall multiply by the expansion of this to see if it really gives us the value that we have there, the expansion there. So we start with 1 minus x over 4 to power a half. So the expansion here gives us what? So it is 1 raised to power half, that is the first term. That is over 0 factorial. Now remember this term here will be negative x over 4 to power 0, the beginning. So it will be power 0. So and anything to power 0 is 1. But we can just as well just write it x over 4 is to power 0. Then over, and just say over 0 factorial. Then plus. Now drop the power. So we have the power of 1, so you drop it there. Then reduce this power by 1. So you shall have 1. A half minus 1 gives you negative a half. Negative a half. Then negative x over 4. Then we had power 0 here, and it becomes power 1. Then over 1 factorial. Then from there, continue to add. Then the third term, remember we are getting only 3 terms. You drop the power again, so you shall have a half, then negative a half, then 1, reduce the power by 1, we have negative 3 over 2, then negative x over 4, then you do what? You square them over 2 to factorial. Now, so we have our terms there. So now simplifying the terms there, what do we get? So we have 1 raised to any power is just 1. This one raised to power 0, and 0 factorial is 1. So we shall just remain with 1. Then 1 raised to any power is 1. Then you have negative x here and you have 4. So 1 times negative of x gives you negative x. Then 2 times 4 times 1. Remember it is this term, then the term that you have here. 1 factorial is 1, so 2 times 4 gives you 8. Then you come to the last term. 1 raised to any power is just 1, so you have 1 times negative 1. Now remember, here you have a negative of x squared. So you have a negative of x squared here. So the negative here just remains. So you shall have a negative. Then 1 times 1 times negative of x squared times x squared, that is will be positive. So you shall have x squared. Then remember, this power applies everything here. So 4 squared here is 16. 16 times 2, 32, 32 times 2, that is 60. 64, then times 2. So 64 times 2, that is 128. So over 128. So the expansion for 1 minus x over 4 to power half half gives you 1 minus x over 8 minus x squared over 28. Now we come to the second expansion, 1 plus x over 4, then to power negative a half. So the procedure again just remains. It is 1 to power negative a half. Then you have this term, x over 4. Then this one is to power 0 over 0 factorial. So most of the time the 0 factorial is not treated, but because it is always 1. Then you have plus, drop the power, so you drop negative a half, reduce the power by 1, so you have negative 3 over 2, then you shall have x over 4, now it will be to power 1, 0, then to power 1, then over 1 factorial, then plus, you have negative a half here, have negative a half, drop the power, negative 3 over 2, then you shall have x over 4. How do you have it? A squared, then at the denominator you have 2. So now expanding that, so we have, remember 1 raised to any power, this one gives you 1. So this one will just have 1. Because 0 to power 0 is 1, 0 factorial is 1, so we shall have 1. Then we have 1 raised to any power is still 1. Then you have negative a half and you have this, so this one will give you negative x over 2 times 2 times 1, which gives you 8. Then we have a negative and a negative here, becomes positive. So we shall have a positive here. Then multiply the numerator terms, this one is 2. So negative 1 times negative 3, that is 3 times x squared, we have 3x squared. Then over, remember this one is 16 square, 4 squared, which gives you 16. 16 times 2 times 2, it gives you 64. 64 times 2, 128. Therefore, you have this expansion and you have this expansion. Therefore, the expansion for 1 minus x over 4 to power half multiplied by 1 plus x over 4 to power negative a half is just given by 1 minus x over 8 minus x squared over 128 multiplied by 1 minus x over 8 plus 3x squared over 128. Now we need to get the terms which only have the square. So now opening up the brackets, we have, so 1 opens up all this expression here. So we shall have 1 times the whole of this gives you 1 minus x over 8 plus 3 over 128x squared. Then you come to the second term, again it opens up the whole of this. So negative x over 8 times 1 gives you negative x over what? X over 8. Then negative and a negative gives you positive x squared. Then 8 times 8 gives you 60, gives you 64. Then you have negative and negative x over 8 times this will give you cubed. So we are not interested with the cubed function, we are only interested with the square. Then we come to the last term. This term opens up this. So we have negative of x squared over 128 times 1 gives you x squared over 128. Therefore, because when you multiply now with this, it will be cubed, then to power 4. Now, taking out, having terms that are alike, so we have 1 is no other constant term. Then you have negative x over 8, negative x over 8, which gives you negative 2. There are 2 of them, right? So negative 2x over 8. Then we come to the square part, the ones that have square. So 3 over 128. So we have 3 over 128. 3 over 128. So 3 over 128. Then which are square plus 1 over 64, right? Then minus 1 over 128. That gives you what? Gives you 1 over 32. So therefore, we have plus minus 1 over 4x plus x squared over 32. And therefore, we have proven that indeed the expansion for this function there, expression is just given by 1 minus x over 4 plus x squared over 32. So this part was on proving. So we can use this equation here to solve this part. So when we have x to be 1 over 16, that means every place you have x, you replace it by 1 over 16 in this equation. So in short, we're saying we have the root 1 minus. So you have x is 1 over 16, right? Then you divide by 4 over 1 plus 1 over 16, then divide by 4 equals to 1 minus 1 over 16, right? Then you divide again by 4 plus 1 over 16 squared, then over 30 over 32. Now remember this just means, so you can just simplify it further. So this fraction here, when you have a fraction here and a whole number, this fraction needs to be down. So this is the same as saying 16 times 4, which gives you 16 times 4 gives you 64. So 1 minus 1 over 64 over 1 plus 1 over 64 equals to 1 minus 1 over 1 over 64. Then plus, what is 16 squared? So 16 squared gives you 256, then you multiply by 32, which gives you 1 over 8192. Now, 1 minus 1 over 64. So 1, subtract 1 over 64. That gives you what? 63 over 64. So in the numerator, we shall just have 63 over 64, and the denominator we shall have 1 plus 1 over 64. 1 plus 1 over 64 gives you, which gives you 65 over 64. 65 over 64. Now you can solve the other side. So we have 1 minus 1 over 64. Then you add 1 over 8192. 8192, which gives you 0.98, 0.9845. So we have that. Now this fraction here, this is the same as saying when you have a fraction divided by another fraction, it's just the same as saying 63 over 64 multiplied by 64 over 65. That cancels with that, 0.9845. So therefore the root of 63 over 65 is just 0.98445. Another example. Determine the first 4 terms of the binomial expansion of 1 over 6 minus x over 2 and state the range of validity. So therefore our solution. Now what is the power in this expression here? Shall note that since you are not given any power, our power is 1, because anything to power 1 is just the same term. So 1 over 6 minus x over 2, this when we say it is to power 1. Then we bring this, the whole of this term, the numerator, so we have 6 minus x over 2, then to power of negative 1. Then we want to rewrite this expression here in the form 1 plus x, then n. 1 plus x raised to power n. So therefore, we want this term here to be 1. Alright? We're doing that because by the end of the day we shall be finding the range of validity, and we shall need the expansion which has been simplified in that form. So now we remove our constant term 6 outside. So we shall have 1 here because 1 times 6 gives you 6. Then divide by 6. So minus x. Now 6 times 2, because we are dividing by 6, this is the same as 1 times 1 over 6. So 6 times 2, which gives you 12, then to power of negative 1. The whole of this family, so the bracket you have 6, negative 1, then you have 1 minus x over 12, power of negative 1. So you have this term, remember 6 to the power negative 1 is just 1 over 6, alright, you can have 6 and then denominator, so this is the same as 6, 1 minus x over 12, then power negative 1. So we have that. So we have simplified this expression here to become something like this. Now we expand this part here, right? We expand the part here. So we shall have 1 over 6, so equals to 1 over 6, then the expansion for that, 1 minus x over 12 to power negative 1 will be given by, so we start with 1 raised to power negative 1, so to power negative 1. So remember, this term here will be 0, and we'll have 0 factorial, so there's no need of writing the other terms. Then we have then plus, drop the power, negative 1, reduce the power by 1, so we have 1 minus 1 minus 1 minus 2, then introduce this term here. It was to power 0 here, then in the next term it will be now to power 1. So and remember it is negative x over 12, then to power 1, you need to write the power over 1 factorial. So this one is over 0 factorial, which is 1. This one is over 1 factorial, which is still 1. So we have that term. Then the third term we have negative 1. You drop negative 2. So 1, negative 2 minus 1, negative 3. Then we have negative x over 12. Then the power, this power now increases to 0, 1, then so we shall have, x, negative x over 12, then to power 2, then over 2 factorial, So that is the third term. Now we go to the fourth term, which is now given by, so you have plus, then you have negative of 1, you have negative of 2, you drop what? Drop negative of 3, then 1 will become to the negative of 4, then you have negative x over 12, then cubed over 3 factorial. So we have that. Now we can simplify that function further. Therefore we have, remember we have 1 over 6 outside. That is very important. And I believe we should add that here too. So 1 over 6. So this one closes there. So now 1 raised to any power is just 1. Then you can simplify this by removing first of all this constant, these ones here. So we shall have plus, we have negative 1, then we have this one becomes 1, then we have negative x over 12, or 1 factorial, then we have plus, we have again negative 1, then you have negative 2, then this one becomes 1. Now you can square this part, so this one squared becomes x squared over 144 over 2 factorial is just 2. Then the last term, this term here, we have negative of 1, negative of 2, negative of 3, 1 raised to any power just becomes 1, then you have x cubed. Now remember, when you cube this function and it has a negative, the negative is retained, right? The negative is retained, so it is negative x cubed over, then you have 12 to power 3, which gives you 1728. We have that, then all over 6, that is 3 factorial. So now we can run that further. 1 over 6, so we have 1, negative gives you positive, so plus x over 12. Then we have negative, which gives you again positive. This one gives you positive. Therefore, 1 times 2 is 2, 2 times x squared is 2x squared. Then you have 144. So you shall have 144 since this is at the denominator, you multiply by 2, which gives you 288, sorry. Then you add, now you're supposed to will be positive. Then multiply the numerators. So 2 times 3 times 1 times 1 gives you 6. Then all the numbers in the numerator, so 1728 you multiply by 6 gives you 10, 3, 6, 8, then x cubed. So that one simplified further. So simplified further, we shall have 1 over 6. Then you have 1 plus x over 12. So this one will be plus 1 over 144x squared, then plus x cubed over 1728. And that is the expansion for that expression. Now we state the validity. So the validity. So the validity there, we say we're going to use this expression here, the expression of x. So we shall have, we know normally our value, our range for x ranges between -1 and 1, but our term x here is negative x over 12. So we shall have -1, negative x over 12, then we have 1, multiply both sides by 12, so we have negative of 12, we have negative of x, then we have 12. Then divide all sides by -1, so we shall have 12. Then inequalities we change, if you divide or multiply by a negative in any side, then you change the inequality there. So we have, this one changes to become greater than x, then we have, this one also changes, becomes negative of 12. Now we are arranging that, it's 12 negative x, then 12. So our range in which that function is valid is between -12 and 12. We check the solution for this. Use binomial theorem to determine the value of the fifth term in the expansion of 3x plus 5y power 10 when x is 1 over 3 and y is given as 1 over 5. So solution we shall have. So we know the r term again is given by c n r a n minus r, and we have b which is given by r, where r is given by r minus 1. Now our n is our power here, then we have our r, we say it is r minus 1, where r is the term that you are finding, the small r. So you are finding the fifth term, so it will be 5, then minus 1, which gives you 4. Then our a is the first term, which is 3x. Our b is the second term, which is 5y. Then what else are we missing? N minus r, which is just 10 minus 4, which gives you 6. Now replacing everything there, the formula we have, so therefore the fifth term is given by combination of 10. We have our r being 4, then our a is 3x given to power 6, then we have 5y given to power 4. So expanding that, so 10 combination 4 gives you 210. We write our values. So we have 210. Then 3 raised to power 6 gives you 729. Then we have x to power 6. Alright. Then we have 5 raised to power 4. So 5 raised to power 4 is 620. 625. Then y to power 4. So you have that expansion. Then replace now the values of x and y. So our x is 1 over 3 and our y is 1 over 5. So therefore we have 210, then we have 729, then x is 1 over 3, then raised to 6. Then we have 625, and 1 over y is 5, 1 over 5, and raised to power 4. So this one is just the same as saying 210, 729, then over 1 over 3 to power 6. 3 to power 6 again, these are 720, 729, and you have 625, 1 over 625. So I believe this one can cancel with that, this one can cancel with that, and you have your value as 200 and what? 210. So we have this example here, show that for small values of x, we have this equation that the cube root 1 over x over 3 is given by plus that is given by that expansion. Then by setting x equals to 2 over 5, determine the value of the cube root of 13 over 17 correct to 3 decimal places. So solution. So now remember, so if we have this expression here, which is the cube root of 1 minus x over 3 over 1 plus x, 1 plus x over 3. This one can be rewritten as 1 minus x over 3, then into bracket the cube root of that, then 1 plus x over 3, then cube root. So yes, put the root of all into the numerator and also the denominator. And again this, you want to remove the term in the denominator and bring it in the numerator, which can now be written as, the whole of this can be written as 1 minus x over 3. Then you have 1 over 3, then 1 plus x over 3. Then, since our power here is positive, it goes in the numerator becomes negative 1 over 3. So therefore, we need to find the expansion for this term, we need to find the expansion for that term, then we multiply the two of them together. So we can start with the first one. Let's start with 1 minus 1 minus x over 3, then to power a third. So power a third. So that's 4 we shall have 1 to power a third. Then the second term will be given by drop the power. Okay, drop the power, reduce the power by 1. What is a third minus 1? Negative 2 over 3, right? Third minus 1 gives you negative 2 over 3. So negative of 2 over 3. Then introduce the term here. So you have negative x over 3. Remember here it is power 0, now here it is power 1. Then you continue. We have a third. Drop the power, negative 2 over 3. Reduce the power by 1. So we have 1. Then we subtract 1. Then you have 5. Negative 5 over 3. So negative of 5 over 3. Then you have negative x over 3. Then this will give us what? Square over 2 factorial. Then the last term given. Remember, we are checking up to x squared. So we shall only have 3 terms at the end of the day. So we only have 3 terms. So therefore we shall have 1 raised to any power is 1. We can derive this one first, then we can open up the bracket. Negative x over 3, then plus 1 over 3, negative 2 over 3. You can open this. When you square, it becomes positive, right? Becomes squared. Then 3 squared is 9 over 2 factorial. 2 factorial is just 2. Now, I can open up the bracket therefore, 1 plus. We have negative a third, and we have positive a third, and we have negative of x over 3. So our term here changes to become negative. So 1 times negative x gives you negative x, 3 times 3 gives you 9. Then you come to the second term. So 1 times negative 2 times x squared gives you negative 2x squared. Then 3 times 3, that is 9. 9 times 9, 81. 81 times 2, 162. So we shall have, it will be negative, remember. So we have that term. You can simplify this by 2, 1 by 2 goes 81. So this one simplifies to become 1 over 81. So we have, now we go to the second term. We have 1 plus x over 3 raised to power negative what? Negative third. Now, again, it's 1 negative a third, that is the first term. And the second term is drop the power, so plus, we drop negative a third. Then reduce the power by 1. So 1, we have negative a third. Negative a third minus 1 gives you negative 4 over 3. So negative 4 over 3. Then I introduce this term here. So x over 3. So it is to power 1. Then come to the next. We have negative a third here. And we have drop the power negative 4 over 3. Right? Then reduce the power by 1 again. We have negative 7 over 3. Then we have x over 3 squared. So if it is a square here, then we have 2 factorial. Now you can simplify this further for opening the bracket. So this one becomes 1. 1 to the power is just 1. And plus negative a third. Then we shall have x over 3. Right? So we shall have 1. Negative a third again, negative 4 over 3. Then this one just becomes 1 again. Then we have x squared. Then 3 squared is 9. Then you have what? 2 factorial, which is just 2. Then, of course, simplifying that becomes 1. You have a negative 1 times x, that gives you negative x over 9. Negative becomes positive. So 4 times x squared gives you plus 4x squared over 3 times 3 is 9. 9 times 9 is 81. 81 times 2, 162. But you can divide that by 2, both of them. So you can have 1 minus x over 9, then plus 2 over 81x squared. So you have the expansion for 1 minus x over 3, then you have the expansion of 1 plus x over 3. Therefore, the multiplication of the 2, so you have 1 plus, so is that the negative x over 3 to power third, then multiply by 1 plus x over 3, then to a third, which is negative. It's just given by the multiplication of the two expansions. So it is 1 minus x over 9, then minus 1 over 81, then we have x squared. So you can have this one as x squared at the numerator there. Then plus 2x squared over 81. So we know this term opens up the whole of that. So we should have 1 minus x over 9 plus 2 over 81x squared. So when 1 multiplies the whole of this, then we come to negative x over 9, again multiplies the whole of this function, then again becomes negative x over 9. So it's this and this, and this becomes positive, so positive x. Now, yeah, correct. So this and this gives you this, and this and this gives you positive, then x squared, then 9 times 9 gives you 81. This and this will give you x cubed. Then you come to the last term, this and this one have minus x squared over 81. So therefore, in short, we shall have 1. We have this term and this term which have the same powers. So negative x over 9, negative x over 9. How many are they? There are 2, but they're negatives. So negative 2 over 9x. Then you come to this term that have square. So you have 2 over 81x squared. Now this term and this term are the same. So this term can cancel with that term. So just remain with plus 2 over 81x squared. And that is the expansion for that value there. And you have proved that indeed this is the expansion for that function. Now, part 2. By setting x equals to 2 over 5, determine the value of the root of 13 over 17. So given by that. Now, we are saying, so for this part, just the solution again, we just replace the values of x in the two equations. So we shall have the root, the cube root of 1 minus, so our x is 2 over 5, so 2 over 5 over 3 over 1. Remember this cube root is over everything, yeah? It becomes clear. Plus 2 over 5 then divided by 3 is given by 1 minus 2 over 9. Our value for x is 2 over 5, then plus 2 over 81, then x squared is 2 over 5, and what? Squared. Now simplify that part. We have 1. Now you have a fraction and you have a constant here, so it's the same as 2 over 15, right? You can say it is 1 minus 2 over 15 over 1 plus 2 over 15 equals to 1 minus 2 times 2 is 9, it's 4, then over 40, over 45, then plus 2, so this is the same as 2 over 81, then we have 4 over 20, over 25. So you can find the value on the left hand side, and you have the value on the right hand side. So we have 1 minus 2 over 15, that gives us 13 over 15, the cube root of 13 over 15 over 1 plus 2 over 15, which gives you 17 over 15. 17 over 15, which now gives us the value of 1 subtract 4 over 45. So we have that plus 2 over 81. Then multiply by 4 over 25. So you get your value as 0.915, 3 decimal places. And this part here just simplifies to become, this is the same as saying 13 over 15. When you are multiplying, so you reciprocate one of the term, the denominator, so that one goes, remain equals to 0.915. So then the cube root of 13 over 17 is 0.915. And that is the solution for that question. So expand the function 1 plus 3x as far, divided by 1 minus 2x as far as the term Knec squared, and set the value of which x is valid. Now, solution. Now we say, when you're not given the power of your expression, the power is always to power 1. So this is the same as saying 1 plus 3x to power 1 over 1 minus 2x to power 1. So rewriting this, we have 1 plus 3x to power 1. Then taking the term in the numerator, we have 1 minus 2x negative of 1. Now this term is already in its most expanded form because it is power 1, so it will just remain the same. So we just have that. Let's expand this function. We have 1 minus 2x, then negative of 1. The expansion for that will be up to, remember it is up to x squared term. So we shall have 1 the power of negative 1, then plus, drop negative 1, then you have 1, reduce this power by 1, you have negative 2, then introduce your second term to power 1. Remember here it is to power 0, here it comes to power 1. Over 1 factorial, this one is over 0 factorial. So then we have negative 1, drop the negative of 2, then you have 1, reduce the power by 1, you have negative of 3, then you have negative of 2x, then you do what? You square that over 2 factorial. Alright? So remember, we are not writing our 0 factorials and 1 factorial in this term and this term because 0 factorial is 1 and 1 factorial is also 1. So simplifying this, we get 1 raised to any power is 1. Then we can just simplify it first before opening. So 1 raised to any power is 1 plus negative 1, negative 2. That one becomes 1, negative. So we can expand this. So remember, this power applies to everything here. So negative 2 squared gives you 4. Then you have x squared. Then over 2 factorial is 2 factorial is 2. So therefore this just gives you 1 negative, so plus 2x. Then these 2 can cancel with these 2 here, get 1. So you have negative 1, which is just positive. So you shall have 4x squared. And that is the expansion. But now remember, we need to get the multiple of this and this. So we have 1 plus 3x. You multiply with 1 minus 2x. So negative 1 just gives us 1 plus 3x. Then multiply by 1 plus 2x plus 4x squared. So therefore, what shall we have? 1 multiplies the whole of this function, so we shall just have, so then gives us 1 plus 2x plus 4x squared. Then 3x multiplies the same function again, so we shall have plus, so 3x times 1, 3x. Then we have 3x times what? 3x times 2x, which gives you 6x squared. This term multiplies with this, it becomes cubed. So we are only interested up to power 2. So we shall have 2x plus 3x gives you 5x. Then you have 4x squared plus 6x squared, which gives you 10x squared. So therefore, your value 1 plus 3x divided by 1 minus 2x expanded up to x to power 2 gives you this function. Now we're supposed to state the validity of the value of x. Now you check the validity of the numerator, check the validity of the denominator. So in the numerator we have 1 plus 3x. So we know normally our value of x ranges between 1 and negative 1 and 1. But here we have what? 3x. So therefore, negative 1, 3x. Then you have 1. So you divide both by 3, by 3, by 3. So you have negative a third x, and we have a third. Now we come to the numerator and we check this term again. 1 minus 2x. So this is not considering the power, it's just considering the term that we have inside here. So we have negative 1x, that is the normal range of the value of x. But here, this time we have negative of 2x, so we have negative 2x, then we have 1. So divide both sides by the negative of 2. Remember again, dividing by a negative changes the inequality. So dividing by negative 2, we shall have negative 1 over negative 2. So this one changes. Then you have x, this one changes again, becomes 1 over negative 2. So you shall have a half x, negative a half there. Now rewriting the equation correctly, the limits, that is, you shall have 1 over 2, then you have x, then you have 1 over But now we are supposed to give a range for the whole function. Now for this, in this case where you have your range being different, we take the range which is a subset of the other. Remember, a third is a subset of a half. So we always pick the value or the range which is a subset of the other. So therefore, in our case, we shall pick a third, negative a third, up to a third as the range in which x will be valid for the whole equation. So therefore, the validity of x is from negative a third x, then a third, and that is the solution. So now let us take an example here. The constant term in the expansion of ax plus b over x raised to power 10 is 64, where a and b are constants, express a in terms of b. So solution. Now, we know one thing, we have our term here, and when you expand it, you get, we want to find the term where the constant term is 64. So what do you know? One thing we know is, for us to have a constant, for us to have a constant term, the power of x must be 0. That is the first condition. The power of x must be 0. So in short, they should know in the term x should not be present, or x should be x raised to power 0. Now, and anything to raise to power 0 is what? Is 1. Now, so if we have this function, if we have this expression, how do we get the r term? The r term is gotten by n r a n minus r b r. Alright? So that is how we get any term. So, but now, let's now come, we assume we don't know the term. So in short, we don't know our r here, we don't know our r, but we know what our f is. So replacing, so we know whichever term we have here, our x value should be 0. Right? Our x value should be 0. So now replacing our a and b values, so we have n, our n is 10. Right? So we have 10, then we have our r, we don't know the answer to that, we have ax, then into bracket, n minus r, then you have b over x, then you have r, that one should give you x equals to 0. Now, remember a and b are constants. So in whichever position the term is, it is not dependent on these constants, but it is dependent on what? On the x alone. Now, for us to find the value, or the term in which the constant occurs, we now take our values only with respect to x. So remember, we know what our n is, so we shall have x. So we shall have only our x, then our n is 10 minus r, then 1 over x. Remember, we are assuming the constants, then r equals to x to power 0. Then, putting that, we have x, 10 minus r. Now, remember, you can bring x, the numerator, that we have x negative 1, r equals to x naught. Therefore, we have x, 10 minus r, then we have x negative r equals to x naught. What do you know about the laws of indices? When you have terms of the same base and different powers, what do you do to the powers? You add the power. So therefore, we have 10 minus r plus minus r, which is just minus r, which should give you 0. So this and this should give you the 0. Yeah? So this is the same as 10 minus 2r equals to 0. So 10 equals to 2r divided by 2. So your r value is equals to 5. That will be 5. So your r value is 5. That is your r value. So if you are asked about the term, which term will it be? Is it the 5th or the 6th? Remember, it is not the 5th term. Alright? So because our r is given by r minus 1. So you have our r 5 equals minus 1, you bring 1 on the other side, so 5 plus 1 equals to r, so our r is 6. So in short, we shall get that will only appear at the 6th term. So the constant will occur at the 6th term. But now, we have now our value for r. We have our value for r. We need to solve now the part of expressing a in terms of So we already know our r is equals to 5. Therefore, we can find the 6th. Remember, this one now is the 6th term. The 6th term is given by, so c, our n is 10, our r is 5. Therefore, our term ax, so we shall have ax raised to power 5. Then we shall have b over x raised to power 5. And what is 10? 10 combination 5. 10 combination 5. We have 10. You combine 5, it gives you 252. So 252. Then you have a to power 5, x to power 5. Then here we shall have b to power 5 over x to power 5. Remember, the power acts on everything inside there, inside the bracket. So this and this cancels out. But now we know something. Our constant term, which is the 6th term, what is the value? 60. It is 8064. 8064. So therefore we have 252 a to power 5 b to power 5 equals to 64. Then divide by 252. Divide by 252. So this goes with that. We have a to power 5 b to power 5 gives you what? 864. Divide by 252, which gives you 32. So remember, in short, what we're trying to do is to make a the subject of the formula. So therefore, if we have a to power 5 equals to a to power 5 b to power 5 equals to 32. So we divide all through by b to power 5 by b to power 5. So we have a to power 5 equals to 32 b to power 5. Now we want to remain with a on this side, so what we do, we get the 5th root on that side, and we get the 5th root on this side. So we have a equals to the 5th root of 32 over b to power 5. And what is a? What is the 5th root of 32? That is definitely 2. And what is the 5th root of b to power 5? So the root of the power cancels, we remain with b. So a very similar question to the one that we've done. So we have the solution. So we are find the term independent of x. That means you're finding the constant term. You're finding the constant term. And we say the constant term is when your x equals to what? X equals to 0. Therefore, your r term, by this case, we just say it is combination of n, r, a, n minus r, then you have your b to power r. What is your n? Your n is 12. Then you have your r there. What is your term at your term? You have x squared, then n, that is 12 minus r. Then you have minus 2 over x, then raised to power r. This will give you again x to power naught, or x to power 0. Again, we take the terms that are only dependent with x. So we shall have here, we shall have x squared, then 12 minus r. Then in our case here, now neglecting the negative of 2, which is a constant, we just have 1 over x, then that we have x to power naught. Now we have a 2, we know by the laws of indices, when you have a, m, then you have a power n, this is the same as a, m, n, alright? We know that from indices. So therefore, we shall have x, opening these powers, we shall have 20, 24, minus 2r. Okay. Then again, our x, we bring it at the numerator. We shall have x or negative 1, and we shall have r. This one should give us x naught. Therefore, joining all that, we shall have x 24 minus 2r minus r. So we shall have 24 minus 2r. Then, okay, let's first of all just write it. Now minus r equals to x naught. Add the powers because we from the law of indices we have am dot an is the same as am plus n. So add this and this, we shall have 24 minus 2r minus r. Therefore, it should give you what? It should give you 0. So you have 24 minus 3r equals to 0. So 24 equals to 3r, then divided by 3, then divided by 3. So this one, your r will be 8. So your r will be 8, but is that the term? No, this is not the term. This is our value for r. Therefore, if we know our r is found by r minus r small r minus 1. So remember, we are finding this term here. We are finding this term. So our r, so we have 8 equals to r minus 1. So your r will be what? Your r will be 9. But now if we want to find the exact term, so now just replacing everything we have. So therefore we know this one is the 9th term. So the 9th term here will be given by, so C, we have our 12, we have our r capital is 8. Then we have our a is x squared raised to power n minus r, 12 minus r, which is 4. Then our term negative 2 over x raised to power 8. Now what is 12? Combination 8. So 12 combination 8 gives you 495. So we shall have 400, right? 495 there. Then we have our x. By the laws of indices, this and this will multiply. We shall have x to power 8. Then you have negative 2 to power 8. Remember, these are an even power, so this negative will go. So we just have 2 raised to power 8. We have 250, 256. Then over, remember it's over x to power 8. What do we see? This one and that one goes. So we have 256 times 495, and that one gives us 126,720. So the term which is independent of x is the term which is the 9th term, and its value is 126,720. So we have another question here. So write down the middle term of the binomial expansion 4x minus 3y at power 8 and calculate its value when x equals to 1 over 4 and y equals to 30. So solution. So we know we're supposed to get the what? The middle term. And this one is an even. We have our power being even. So when we have our power being even, the middle term is found by n over 2 plus 1. So what is our n? Our n is 8 over 2, which gives you 4. 4 plus 1, which gives you 5. So we are getting the fifth term. So that is our r, our small r. Now we know how do we get any term. So the r term is gotten by n r a n minus r b. Then you have r, where your r is found by r minus 1. So let's get everything we need. Our n is 8. Our r is given by r minus 1, so 5 minus 1, which gives you 4. Our a is given by our first term there, which is 4x. Our b is given by negative of 3y. So replacing everything that we need, so we have equals 2, so our n is 8, our r is 4, our a is 4x, our b is negative 3y, then we shall have this one raised to power 4, this one raised to power 4. Because remember again, the summation of this power and this power must be equal to our n here. So in short, we have 8 combination 4. So we have 8 combination 4 gives you 70. Then you have 4 to power 4. 4 to power 4 gives you 256. Then you have x to power 4. Then 3 to power 4, that should be 81. 81, right? So 81. Then y to power 4. Remember, why is it 81 which is positive? Our power here is an even power. So this negative will by the end of the day become a positive. So our value therefore there we have 70, then times 256. So 70 times 256 times 81. So you have your values as 1451 520 x to power 4 y to power 4. Now replacing our values of x and y, in that we shall have so an x is equals to, so we can have an x equals to 1 over 4 and your y equals to 1 over 3. Therefore our term, that is the fifth term, will be given by 145152 0. Then we have 1 over 4 raised to power 4, then 1 over 3 raised to power 4, right? Now you can see this is just the same as 1451520. Then 4 raised to power 4, it gives you 256. Then 1 over 3 raised to power 4 gives you 81. So you can just backtrack here. We have an 81, we have an 256. So in this equation by the end of the day, we have a 256 here and we have an 81 here. So in short, you just remain this term here. But you can confirm through working that indeed the solution is 70. So we have an example. Determine the first three terms of the binomial expansion, 1 minus 2x raised to power negative a half. Then the second part of it is by setting x equals to 1 over 10. Determine the value over the root of 80 to 3 decimal places. So solution. So we start by first of all expanding. So we have 1 minus 2x, then negative a half. So we have, this will be 1 raised to power negative a half, that will be the first term. Then plus, drop the half, right? Then reduce the power of 1 by a half. So negative a half minus 1 gives you negative 3 over 2. Then introduce your second term to power 1. Then the last term that we need to get, we are supposed to get only the first three terms. Then we shall have, we have negative a half, drop negative 3 over 2. Then we shall have 1 raised to power negative 5 over 2. Then we have negative of 2x. This one will be squared, then over 2 factorial. Therefore, 1 to any power just gives you 1. So plus, you can simplify this one first. Then this one will be 1, have negative 2x. Then plus, you have negative a half, negative 3 over 2. Then this one becomes 1. Then you have negative of 2x. We can open this part. So negative of 2 squared gives you 4. Then x squared gives you x squared. Then 2 factorial is just 2. Therefore, expanding this, we have 1. These are negative and a negative, and you have a 2, the 2 and the 2 cancels, then negative and negative becomes positive. So we have plus x. Then we have a negative and a negative again becomes positive. So our term here will be positive. Then you have 3 times 4, which gives you 12. That is the term, the numerator. Then 2 times 2 times 2 gives you 8. So over 8. Then x squared. So we have 1 plus x, then plus cancelling by 4. By 4 goes 3, then 2x squared. So that is the expansion for 1 minus 2x raised to 1 negative half. Now, setting x equals to 1 over 10, determine the value of root 1 over root of 80. So replacing, so we know 1 minus 2x, expansion of it gives you negative a half. That should give you 1 plus x, then plus 3 over 2x what? X squared. Now replacing the values of x, as well, with 1 over 10, 1 minus 2, 1 over 10, then into brackets, then negative a half. Which gives you 1 plus 1 over 10 plus 3 over 2. 1 over 10 is over 2. Then you have 1 over 10 squared. So, by the end of the day, you shall have 1 minus 1 over 5. Then all of that, negative a half, equals to 1 plus 1 over 10 plus 3 over, this one will be 100, 100 times 2, 200. Now, what is 1 minus 1 over 5? That gives you 4 over 5. Okay, it is 4 over 5 into brackets, negative of the root. Now, then evaluating the right hand side, you have 1 plus 1 over 10, then plus 3 over what? 3 over 200, which gives you 1.115. Now remember, we can rewrite this to give this a positive power. So we can rewrite this as a positive power, and we shall have 5 over 4. You now just reciprocate, because remember, this is a fraction. This is a fraction, so when you reciprocate it, the power becomes positive, then 1.115. But now we want the root of what? We want the root of 1 over root of 80. So you can see this fraction is nothing near 1 over the root of 80. So you can make this, so multiply both sides by the root of 80. So just have 1 over root of 80 that side. Then what you do on the left hand side, also do on the right hand side. And from there, so this we multiply with the root of 80, so this one remains. So we shall have, so multiply by 1 over the root of 80. What do you get? You get 1 over the root of 80. We have 5 over 4, then a half equals to 0.12466. So you can put that. Now we want to remain with the root of 80 this side. We want to remain with the root of 80. So we just multiply, divide by what? Divide by 5 over 4, then divide by half, and also on that side, 5 over 4, then a half. So just make 1 over the root of 80 gives us. So our answer there, and we divide by the root, divided by the root of 5 over 4. And that gives you 0.1115. So to 3 decimal places gives you 1 over the root of 80 is just 0.112. And you can confirm if your answer indeed 1 over the root of 80